Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and I'm doing another a solution to another daily math problem I posted a few days ago. This one involving approximations of pi with periodic continued fractions. Show a couple examples above. So anyway, let's begin. So here's the specific problem. We want to find the number closest to pi with a purely periodic continued fraction with period of length 2. And I think you can see that these two examples have that form. And what this means, when I put the terms in parentheses, this just means that those terms are repeated indefinitely. And there's no pre-period in this case. So it starts with an expression in parentheses. So anyway, so maybe I should give you a little bit of overview of continued fractions before we continue, because you might not be that familiar with them. But it turns out if we have two numbers x, which I'm calling x here, x has continued fraction coefficients a0, a1, a2, so on. What that really means is a0 plus 1 over the fraction a1 plus 1 over the fraction a2, and so on. And similarly for y is a number with continued fractions b0, b1, b2. So how in general do we determine which one is greater and which one is less? Well, there is a procedure. I mean, obviously, if each of these continued fractions just had one term, or say a0 was less than b0, well, that if x starts with a0, that means that x is between a0 and a0 plus 1, because a0 is the floor of x. The leading coefficient of any continued fraction is just its floor. So if the leading coefficient of x was less than the leading coefficient of y, we can conclude that x is less than y. But what if they have more than one term? In other words, they're not both integers. Say x starts out a0, a1, y starts out a0, b1, because I'm assuming that b0 is equal to a0. And let's now assume that a1 is less than b1. Well, now in this case, it turns out that x is greater than y. And I don't think that's too hard to see, because a1's in the denominator. Remember a0, the number with continued fraction a0, a1 starts out a0 plus 1 over a1. And then for b, it would be a0 plus 1 over b1. But if b1 was greater than a1, that would be 1 over b1 is less than 1 over a1. So that would mean that y is less than x, or in other words, x is greater than y. And I think you can convince yourself that this kind of goes back and forth. So to determine which of two continued fractions is greater, if the first place in which the continued fraction coefficients differs has a even index, for if the index is 0, obviously it's true that the one with a greater coefficient, zeroth coefficient is going to be greater. And similarly, it's going to be true for any even. So if A2 and B2 were the first place where they differed, and A2 was less than B2, we would conclude that X is less than Y. And in general, for odd, it's the other way around. So that's how we determine which is greater and which is less. And there's a couple other facts we need here. The continued fraction of pi starts out 3 comma 7 comma 15. You don't really need to know any more than that. That's all I'm giving here. That already gives you a really excellent approximation of pi, by the way. But let's look at these. So now we want to find periodic continued fractions, purely periodic with period 2. So these would all have the form a0 comma a1 in parentheses. That means a0 plus 1 over a1 plus 1 over a0 plus 1 over a1 and so on, ad infinitum. And clearly a0 has to be 3 in order for this to be a good pi approximation. Because if a0 was less than 3, that would mean that this number is less than 3. And if a0 was greater than 3, it would mean the number is greater than 3. But we don't want that, because there's periodic continued fractions of if they're equal to 3. We know that the number, the continued fraction is between 3 and 4. That's what we want. Those are closer than anything that's less than 3 or greater than 3. So anyway, um, so we might as well look at a couple. Then we know it has the form 3 comma a1, and since pi starts out 3 comma 7, um, it turns out. So let's look at I'm defining u to be 3 comma 7. And that would mean 3 comma 7 comma per repeating. So that would be 3 comma 7 comma 3 comma 7, so on. Yeah, notice that the first place in which that differs from pi is in the A2. Uh, and for pi, it's 15. And since it has an even index, that means that the continued fraction of pi is greater. Pi is greater than this thing I'm calling u. But what about v? V is the one with 3 comma 6 repeating. Well, this time they differ in the first in the continued fraction coefficient with index 1. V this time has a smaller index 6 than the corresponding index of pi, which is 7. Since 6 is less than 7, remember that's an odd coefficient. That means that v is going to be greater than pi. Or pi is less than v, if you like. So we just found it double inequality here. U is less than pi, and pi is less than v. Well, that's what we want, because any other periodic continued fraction with period 2, purely periodic, is going to be farther away from pi than these two examples. That's not hard to see either. For instance, 3 comma 5 is going to be even bigger than v, even farther away from pi than v. And 3 comma 8 is going to be smaller than u. So I think you can see all the examples these are the two closest ones. So these are the only two we have to consider. So the only thing left to do is compute u on v. And that's easy enough to do. And I don't know how well you guys can see these slides. They're a little hard to see, but first I'm going to start with u. So u is the one with periodic continued fraction 3 comma 7 repeating, and that's just going to be equal to 3 plus 1 over 7 plus 1 over 3 plus 1 over 7 and so on. But we can write as 3 plus 1 over 7 plus 1 over u. So now we have an equation involving u as a continued fraction involving u, and we can solve it. I mean, all we have to do is simplify this ugly fraction on the right, this continued fraction on the right. And, you can start by multiplying both the numerator and denominator by u. You get u equals 3 plus u over 7u plus 1. And we can write that as a single fraction, an improper fraction, I guess. 22u plus 3 over 7u plus 1. So we have u equals 22u plus 3 over 7u plus 1. Next, we just multiply both sides by 7u plus 1. We get u times 7u plus 1 equals 22u plus 3. And if you simplify this algebraic expression, put everything on the right side to 0, you'll get a quadratic equation. 7u squared minus 21u minus 3 equals 0. And now we can just apply the quadratic formula to solve for u. I'm sure you guys all remember the quadratic formula. Negative b plus or minus b squared minus 4 square root of b squared minus 4ac all over 2a. And we want to take the plus sign in front of the square root because it turns out one of the roots is negative. We don't want the negative root. So when you do this and you simplify, you find that u is equal to 21 plus 5 times the square root of 21 all over 4. And that's easy enough to calculate with a calculator or with a computer. I did it with Mathematica, but you can do it with pretty much any calculator. You get approximately 3.13663, which I think you can see is less than pi, a little bit less than pi. Turns out the difference, u minus pi, is it's going to be negative because it's less than pi. The difference is approximately minus 0.00496, or about 1 part in 200. So it is a good approximation of pi. Actually, it's not even as good approximation of pi as 22 over 7. That only differs from pi by about 1 part in 700, I think. I didn't say these are necessarily very good approximations, but They are approximations of pi. So what about v? Let's do v next. So v is the number with continued fraction, periodic continued fraction, 3 comma 6 repeating. In other words, 3 comma 6 comma 3 comma 6 ad nauseum. And we can do the same thing we did for u. We can write this as 3 plus 1 over 6 plus 1 over v. And then we can just algebraically simplify everything. You find v is equal to 19v plus 3 over 6v plus 1. Multiply both sides by 6v plus 1. Simplify, you get a quadratic equation. 6v squared minus 18v minus 3 equals 0. And once again, you can apply the quadratic formula. Simplify, note that one of the roots of this quadratic equation is negative, so we don't want that one. But the positive root turns out to be, after you simplify it, 3 plus the square root of 11 all over 2, which is approximately 3.15831. Like I said, it is bigger than pi. And once again, we calculate the difference. It turns out v minus pi is approximately 0.01672, or about 1 part in 60. So it's not as good as u. V is further from pi than u. That means the answer to our problem is u. It's the value I gave you already. 21 plus 5 times the square root of 21 all over 14, which is approximately 3.13663. So that is the number with a purely periodic fraction, continued fraction period length 2 that's closest to pi. Anyway, that completes the problem. Thank you for watching. Long live math, and I'll see you guys next time. Bye.